Okay, let's cover a few binary to decimal conversion values. No charts needed here in advance. We just need to know powers of two, and I'm going to set up a system to show you how to do this. And probably, I guess you have to know how to add in decimal, and we'll assume you know how to do that right away. So let's take something a little bit easier first to establish the procedure. I have this binary number and I want to convert it to decimal. So what I usually do is draw little underlines under each of these positions. And I know this least significant bit is the 2 to the 0 position, and 2 to the 1, 2 to the 2, and 2 to the 3, and so on as it goes up there. Um, that's great to know, and I need to know that, but probably um, the decimal equivalents of those powers of 2 are probably what I really want to know. So I'm writing those decimal equivalents. This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. I'm writing them below there. And everywhere there's a 1, I'm going to include that in my addition down here. So in this position, there's a 1, and I'm going to write the 8. I'm going to write the value of that position. In this position is 0. I'm not going to write anything because 0 times 4 is 0. But 2 times 1 is 2. That's the 2 position, and this is 0. When I add those together, I get 10. And that is the answer that I'm looking for. And since I've done binary for a long time, I know that is the right answer. I could do a decimal to binary conversion. We have that in another video, and you probably should double check that and go back through there. So in the I want to be short here. Let me erase this and let's do it again. We got the procedure established. Let's use something a little bit more involved. Let me get my pen and I'm going to write 1 0 1 0 1 1 1 0 1 0 1. And that's my binary number. I'm going to want to convert that to decimal. So once again, you don't have to write these little underlined things. I think it helps me keep track of stuff. Um, that's up to you. Uh, so this is 1, 2, 4, 8, 16. I might start to write them sideways so I don't get them running in each 32, 64, 128 power, 256 power, 512 power, and 1024. Those are the powers of 2. So 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Okay, just checking to make sure I got those right. Now, any place there's a 1, that's a decimal value that I'm going to want to add. This is going to be a little bit more harder to do, so let's line it up in a conventional addition fashion. So 1024 plus 256. Let's do that addition. I don't know if you knew this, but you really can only add 2 numbers at a time. That's how you were taught. So that's 0 carried a 1, 7, 8, right? And that's a 2, and that's a 1. So that takes care of these 2 positions, 1024 plus 256. Then I'm going to add 64, 32, and 16. So 64. Hopefully I'm doing this all right. If I'm not, please let me know. I'll fix the video up. But 64, 32 is my next addition. 6, 7, 3, 1, and 16. So I add the 16 here. And 2 carry the 1, 7, 8, 9, 3, and 1. Okay, I got to here, and I have what, a 4 and a 1 yet to add base there. So 4 and 1 is 6. I'm going to do that all at one time. If you're good at math, take the shortcuts. So 1, 9, 3, 6, 8, base 10. And based on what I see, if I didn't make any stupid little errors, I think that's correct. Technician wise, I probably would walk that back in a different direction, but we'll leave that for other videos and other skills to do it. But that's basically the procedures and the skills that you do for a binary to a decimal conversion. Once again, procedures that are very consistent with other numbering systems. So math-wise, we're probably not asking you to learn any new concepts here. We might be confusing you a little bit by putting three different numbering systems up here and asking them to learn them very quickly, but we're asking you to recall procedures from the past and apply them with different powers. And from doing this for a long time, the only thing I see is mostly students getting confused. And hopefully that helps. Come back here and look at this, work your own problems, do it till you cannot get them wrong. Thank you.